So on today's video, we're going to look at a workflow for clusters, star clusters, such as the one that we're going to work through, the M71. I'm going to presume that you've already pre-processed through stacking your image, and whether you've used Deep Sky Stacker, whether you've used PixInsight, or whether you've used Astro Pixel Processor. So I've opened up my stacked image of M71 into PixInsight. Opens up quite dark, but obviously this is how we're going to process it. And if we use the STF auto stretch function in the top right hand corner, we can get an idea of what we're going to be working with. So the cluster is right there in the middle. And to start with, as we can see here, we've got a bit of a dust bunny, which the flats have not worked out, unfortunately. But we're going to crop first the image, as what we're going to be working with is the central area, as opposed to everything outside as well. So to start cropping, I'm just going to actually increase the window a little bit just so we can see the full image, and resize the image to the window, zoom to fit. And the first thing we're going to do, as I said, is a dynamic crop. So dynamic crop allows us to remove or crop out what we don't want to have in our image. So I'm just going to draw a box across, and you can see there in the center there's a circle and a cross, and we're going to try and get that positioned right in the middle of this cluster. So as I said, I'm going to zoom in a little bit, as the cluster is what we are interested in. I just want to try and keep these nice 3 singular stars at the bottom there as well. They'll probably look nice in the final image. So just crop this to suit. So obviously this is, I guess each cluster is slightly different. And what you have in the surrounding area of the clusters will be different from object to object as well. But yeah, just crop out what you feel best or what you want to remove. So once I've done that, we're not going to change the rotation or anything on this one at the minute. We're just going to execute or apply the crop. Okay, and just zoom to fit again, and there's the cluster cropped out, or sorry, the area cropped out around the cluster, and this is what we're going to be working with. Okay, so the next process that we're going to run through is DBE, or dynamic background extraction. And let's just load this process up first so we can see it. The dynamic background extraction, what that does is it corrects any unwanted signals within the image. Now, specifically, unwanted signals may be gradients or different levels of brightnesses across the image, which could come from, I don't know, maybe light pollution from the moon, street lights, etc., or even perhaps amp glow from your camera. So DBE calculates the sampled data, which we'll do in a minute, and then it removes that away from the actual image itself, giving us a more flattened image as opposed to like perhaps gradient. So not sure whether this picks up, but certainly on the right hand side of my image at the minute is a lot more darker than perhaps the left hand side or the bottom left hand side of the image. So DBE, the first thing we have to do, we click on the image itself. So the first thing we need to do is set the parameters for it to auto-generate the samples across the image. Now, depending on the actual image, you may find you want to use different values for this. I'm just going to set a tolerance of 1. I'm going to set a default sample radius to 15 and samples per row to 10 that I want to try and generate. And then what I'm going to do here is just click on the sample color, which is gray, and I'm going to move the sliders 2 up and 1 down to yellow, and you'll see in a second that yellow color just allows us to see the samples that's generated a little bit more easier. and then click on generate. Okay, so you can see there for the majority of the image, it has generated the samples. So the size of the samples are based on the default sample radius. If we increase that to say 30 and resize all, you can see the sample increases. Just going to change that back down to 15. The tolerance, which is set at 1, this is basically the parameter which is deciding whether it calculates whether a sample is created or not. So if we just increase that to 3 again and generate, you can see there with the tolerance being a lot higher, it has actually placed all of the samples for us across the image. Likewise, if we were to drop this down to 0.5, it's going to generate us a lot less samples as well. Actually, 2 with that number there, too few samples. So let's put this back to say 1.5. Okay, and the majority of the image there is covered with samples. So what we want to do next is, out of our 71 samples that have been created, we need to make sure that the samples are covering the background of the image, hence dynamic background extraction. We don't want any of these samples, as an example, to be covered on a star, because that is not the background and that is not what we are calculating against. So how can we tell if we're covered against a star? Well, if the sample on the right-hand side is heavily black, or that the pixels are heavily black, then that probably means we are covering a star. Whereas if we are on a background that is not a star, the pixels are more likely to be white. So we need to make sure that these 71 samples are white, and all we do that, easy way to do that, is we zoom into an area first. So we'll start in the top left here, and from our first sample, we're just going to choose an area, just click and drag with the mouse an area where the majority is white and not black. So we know that we are not highlighting a star and we are covering the background instead. And we'll just go through these sample by sample. It doesn't have to be, we're not going to get 100% white every single time, but we need to be near abouts. And we'll also need to make sure that if we do drag a sample, we're not taking this sample away from the area that it was originally calculated against. So I'm probably just going to fast forward the video at this point while I go through the 71 samples to make sure that they are, for the majority of the area, covering the black background, and as I said, not the foreground. So I'll just fast forward through that now and we'll return after I've completed this. Okay, so I've been through the samples there and moved a lot of them around. Rather than having to feel everyone has to be, in an exact place sampling the background, if you can't find an area, it's okay to delete one of the samples, especially when we've got this many samples. And the other thing is, obviously, you don't want any samples right in the middle of the image or the cluster itself, because you definitely will not be sampling the background. So before we run this process, the last thing we want to check is that on the target image correction, we want the correction to be subtraction. So this is when it's calculated the background reference, the result is removed from our image. I'm just going to choose, well, I'm not going to choose any of these, but if you want to skip a step, you can discard the background model and you can replace the target image. For the minute, I'm just going to keep those so we can see the difference between the two a little bit easier. Okay, so I'm just going to execute that against the image. Okay, and that was done quickly. So what we've got here, just move the process out of the way. If we stretch the two images that's created us. So this one on the left here, underscore background, we'll just expand this out and zoom to fit. That's the image that is going to be subtracted. There we go, that's a little bit easier. So as I was saying, on the right hand side, compared to the left hand side of my original image, there was a difference in the light and dark, and this has also been picked up in the background as well. And this is this background image that we're looking at here is what will be removed or subtracted from the original image. So this just allows you to see the gradient of what the actual sampling and process picked up. So this is actually being subtracted automatically. This is just for visual references. So I can just close this. And then the right-hand side here is our image that it's created, and it's added DBE onto the postfix of the title, just so we can see that the process has been run. Okay, so let's just close background dynamic extraction. We don't need the original file. Yes, we can close that, and we'll just continue moving forward with this new processed image here, as I said, with DBE, and we'll just zoom to fit and we can see what we're starting to get. So if we remove the STF screen transfer function, this is what the actual image looks like right now, but applying the STF, that allows us just to kind of see what we are working towards. So before we start working on the noise of this image, we're going to set up or color calibrate the image using photometric color calibration. So I've just moved this to the side and we'll start the process. So photometric color calibration. So basically what this tool or process does is, through plate solving our image, it then knows exactly what the image is, where the object is, and looking through, I guess, a database of photometry data against the calculated object, it brings through I guess a record of what the image colors should be there or thereabouts. So to do this, all I'm going to do is search the coordinates for our object, which is M71. Search and it finds, and then it updates the right ascension and declination location of the object. The observation date doesn't have to be precise down to the minute, but at least the month, and I've found sometimes the actual day is required for accuracy. Total length of my telescope and flattener is 480 millimeters, and the pixel size of my camera 3.72. Okay. The other options we're just going to use as is. I do have a video on how to download and use a local catalog or database. So if this is not working online or the server is off line, which sometimes it is, then you might want to try downloading a catalog locally and using that instead. The last setting here, which we're going to look at, is the background neutralization, and we're going to set the upper limit, which basically says that anything that is equal or larger to this limit will be rejected or ignored for any background calculations or background neutralization. So to find a value for that, I'm just going to remove the boost stretch. I'm just going to scroll around looking for some dim stars. So I'm looking at the bottom here, 0048, 0082, and 01. So, okay, so because we don't want to neutralize the dim stars, I'm just going to set this just to 0.01. Okay, and that'll make sure it kind of like separates the dim stars to the actual background itself. And then we'll just run the calculation or the process. So it's plate solving to make sure it knows what the object is, using the ascension declination and also the observation date. Okay, so that's complete, and the results of the graphs, what I believe is the greens are all of the stars or the areas that's identified, and it just shows a graph of how much calibration was needed between what I originally had and what the photometric color calibration process did. You can click on the little question mark or help text, and that explains these graphs in a little bit more detail. However, just let's close that. We can also close the photometric calibration process itself. And then if we do we'll re-stretch this. This is what we've currently got after the calibration. And we can do an undo and a redo just to see the difference. Background is certainly clearer, and it's definitely taking away a green slant or hue against the object or the M71 itself. So hopefully that shows that photometric calibration has certainly done its thing. So just to finish off the color calibration, what I normally run here is the DCNR process. So just load that process up, DCNR. And from a visual point of view, what this does is it kind of removes the color to remove red, green, and blue. In this instance, we're going to choose green just to remove that final hint of green. But basically what it's doing, it's subtracting the chromatic noise within the image, within this color. I'm just going to reduce this down to about 0.4. Again, try this per image, depending on what you've imaged, what your target is, how you've taken it, etc. You might need a little different amount of what I'm trying. So let's go ahead and apply this. It is a quick process, so we don't need any previews at the minute. And again, we can undo and redo just to see the difference. So what I'm going to do, I'm going to undo this, slightly increase it a little bit more, so about 50-50. So this is increasing the amount of removal. And we'll try that again, and that looks a little bit better. So again, I'm not sure whether the compression of this video or YouTube makes much difference, but I'm happy with a slightly higher amount on that. Okay, so that's DCNR done. Let's close that now. Okay, so the next thing we're going to do while still focusing on the color is boost the actual star color itself. This time using a script called Repair HSV Separation, which is in the script Utilities Repaired HSV Separation script. And what we need to do for this is if we unstretch and zoom into one of our saturated stars, which is down the bottom here. And how the script works is it looks for the color around the star itself, and it fills in the saturated center of the star. So let's just find some saturated stars. Okay, so here's one here with white center but color around the edge. And we just looking at the RGB values at the bottom. We just want to take the lowest value, or remember the lowest value, so about around 0.1 there. Let's see if we can find some other saturated stars for comparison. Let's have this one. Okay, so this is saturated in the middle bite, but colors around the edge. Some 0.1, 0.2. Okay, so let's go for 0.1. 0.15. So back for the script, and I'll show you where we use that value. And in the repair level, 0.15. We want to check the V, no repairs, and set everything else as is. You can measure, I guess, what your largest star is for the radius. I'm just going to set this at 16 or leave that at 16. But as I've said before, please try different settings or values depending on your own images. So we're going to run that script, and it's going to create several windows for us. Okay, so we'll just have generally when there's an output of these, I just boost, or sorry, stretch, just so you have an idea of what the actual windows contain. That's our original. Oh, too many clicks. Okay, so this is the output of the script itself. So what I want to do with these images is combine them again using channel combination. So process channel combination. And instead of RGB, we want to choose HSV and check HSV itself, and we'll just choose these images, or we'll leave it as auto. But the _H is our H channel, SV is the SV, and the V itself is the unrepaired. And we'll just run this channel combination process, and that's the completion of that star boosting. So let's close this out of the way so we can have a look. We're going to minimize all these, get them out of the way. And there's our new image. I'm just going to rename that to M71 RGB. And then if we stretch this, we should see the output of the repaired HSV channels being recombined using channel combination. And moving forward, we'll continue with the M71 RGB image. Okay. And our previous one, we'll just minimize and keep out the way in the corner there. So hopefully anywhere where we've had stars that have been too saturated in the middle, the colors around them have actually been, or the saturated part of the stars have been replaced with the colors around the perimeter of the stars. But thankfully we've still got these nice 3 stars at the bottom here. And if we just zoom in, we've still got some noise, or we haven't removed the noise yet. But the stars should have a lot more color boost within them as opposed to just a white saturation in the middle. Okay, so we're going to move into the noise reduction process, and for this I'm going to follow some steps from a John Reister website, or his chapter specifically on effective noise reduction, and I'll paste those links into the description below this video. So to start with, we need to extract the luminance channel. And what we want to do then is permanently stretch this luminance image here. So to do that, we open the screen transformation and histogram. Just reset both of these and press the nuke button to create the stretch against the luminance for us. However, we need to permanently apply that to the image. So we'll drag the triangle into the histogram transformation, and then drag the triangle from the histogram and transformation into the luminous image. And we are what I call double stretched here. So if we remove the stretch from the luminance image, we've finally applied that actual stretch to it. So we need to duplicate this twice because we're going to be using 2 processes, one TGV, and duplicate it again and rename this one to MMT. Okay. So before we can use these in the actual processes, we need to slightly tweak these cloned luminance images. So for the TGV one first, we're going to go to curves transformation. Just reset this, hit the preview so we can see what's going on. And we're just going to slightly raise this left-hand side point just below the line. And also likewise, this top one, we're just going to bring down to just above midway point. And this is going to create us a low contrast mask is what we're trying to get here. So apply that curves transformation. I'll just close the preview, sorry. Apply the curves transformation. And then the next thing we want to do on this again, before using it within the process, is we'll go to histogram transformation. Actually, we've still got this open. Just reset and make sure that we've got the TGV luminance selected. And what we're going to do here, just resetting that, yeah. So what we're going to do here is basically want to bring this top peak along to about the middle of the top chart. Okay, there we go. So I've just moved this slider along in the middle here. This is adjusting the midtones to the middle, and then we're going to apply that in there, and we've got a low contrast mask that we can use. Okay, so we're going to apply this TGV image to our RGB one. And remember, anything that is red is protected. So the background is protected at the minute, and we actually want to remove the noise from the background. So we're going to invert mask. And then we will just enable show mask. Okay, so we know the mask is applied because in this top left-hand corner tab, it's a reddish brown showing that a mask is currently being applied. So we can finally run the TGV noise process. Just go move this along and open this up. So everything in here just leave as is. However, you will find different mileage in your own images. So to start with, I'm just going to reduce the edge protection to -5 or strength, sorry, not strength 5, but to -5 on the right-hand side. And then the other thing we're going to do is we're going to check local support and make sure that our original luminance, which remember was _L for us, is the local support image. Let's create a preview. So rather than run it on the entire image, we can just see a small area first, and it's a bit quicker as well to run. And we'll apply the TGV denoise process to that preview. If we zoom in, we can see how the noise has been smoothed out. There was the noise before, and there was the noise after. Now, one of the things that John Riester advises is to increase the number of iterations, because when you're dealing with noise, it's a very subtle process. So let's increase this to 500, and again, apply that to our preview and see if that improves anything further. So with 500 iterations, it will take a little bit longer than just running it on the 100 iterations. Okay, so we can see before and after on that. Just zooming out, it looks okay or fine for the preview. So let's remove or delete all previews, and then we will apply those same settings to the full image itself. Much larger image than the preview, 500 iterations to make sure it's nice and gentle, nice and smooth. So this could take a few minutes. So I'll fast forward the video at this point. Okay, so the TGV noise process is finished, and next we're going to move on to some more medium and low frequency noise reductions, as John Rister described it. So we're going to be working with our other MMT mask that we've created, but first we're going to remove the previous one. So the MMT mask, again, we need to do some slight corrections to it. So we're going to open up histogram transformation, reset the settings and point to MMT. And this time we want to bring the top peak across much higher than 70–75%. So I'm just going to move the mid-tone slider right across, and that'll increase it. If I put preview on, you can see what we're doing with this one. And then the next step that I want to do, so I'm just going to apply that histogram transformation against it to create our mask, or the mask type that we require. And the process we're going to use this time for this mask is multi-scale median transform. Okay, so when you load this for the first time, there'll only be 4 layers with all the parameters being empty. However, again, based on John Rister's settings for effective noise reduction, these are the parameters in 8 layers that he suggests. The other thing that change at the bottom is the target of the luminance. So this is where the multiscale median transform will be targeted against. And so just move this to the side. We're going to apply this mask to our image. Show the mask, and just to double check, remember it's the background we want to be applying this process to, so invert the mask. So our stars are all marked solid red. Not going to show the mask, however, again, we know it's applied. Go to preview, let's create us a preview window. And against the preview, we will run the process. Zoom in here, hopefully we can see a before and after. So there's the before and the after. The noise has been flattened out quite gently or subtly on this, but at least again, step by step, we're slowly removing our background noise. Okay, so I'm going to delete the preview on that, and we will apply the process to our full image. Okay, and if we zoom in, we should be able to see a before and after with the undo. So again, subtle, but step by step, increasing or reducing the noise, rather, the background noise. Okay, so I'm going to remove the mask, and we'll close down the multi-scale median transform. Okay, so we're going to move into the non-linear processing stages, which is basically working with or processing or stretching the data. And the first thing we're going to do is we're going to do an arc sine stretch against this. So using the arc sine stretch, again, we're going to hit a preview on this, just reset everything so we can see what's going on. We're going to use the estimate black point, and we're going to protect the highlights so data is not clipped. That shouldn't be. The double stretch, sorry, so we can see what's going on there. So yeah, so the bottom slider will reduce or show any red specks that are going to be clipped out. I'm just going to drop this a little bit further, and then we'll apply the arc sine stretch to the image itself. So of course you can manually stretch this using the curves if you want to, or you can actually draw out arc sine curve yourself. But the actual arc sine stretch process, I think, does a good job of this, obviously being a little bit automated and calculated. Okay, so if we once applied, if we go to the histogram transformation, just reset this, make sure the RGB image is selected. And if these curves were too much to the left-hand side, then basically we've clipped too much of the data. We haven't protected the data. So we've got a slight gap there. So hopefully none of the data was clipped using the Sine process. So all I'm going to do here is I want to move, again, following suggestions from John Riesta's website, is we want to move this top curve a little bit more to the right after the initial stretch. So we're just going to do that with the mid-tone slider again, pulling this across. Sorry, I'll just put a preview on. So just move that mid-tone slider until the peak is on the first dotted line, and that should complete our stretch. So I'm just going to apply the histogram transformation changes to the actual image itself, and that's starting to set the background and the foreground with the colors and the stars, etc., quite nicely. So because we're in this non-linear state, we obviously have created a little bit more noise when we have stretched things. So to remove that noise, we're going to use a process called ACDNR, which, as John Riesta suggests, that this should be used after our initial stretch, where we've probably created a little bit more background noise. So before we use the ACDNR process, of course, we need to create a mask to protect the stars and just focus on the noise in the background. So we're going to create or extract the luminance channel. And like previously, we're going to nuke or stretch the luminance channel. And then we're going to apply this to our histogram transformation. Just reset that. Select our L1 luminance that we've just created. Apply that in. And then we're just going to move the mid-tone so that the top peak is in the middle. And we'll apply this to the luminance channel, and that gives us our mask, for which we'll use on ACDNR. Okay, so let's drag this into our image, applying the mask per usual. Show the mask, however, remember we need to invert it so that the stars are all protected with a solid red, and it is the background that we will be applying this process to. And I'm just going to unshow the mask. Okay, so I'm just going to reset ACDNR and using the values as a starting point suggested by John Riesta. So on the lightness, 1.5, amount, dropping that to 0.5. I think we leave everything as is, but reduce the structure size. And the section at the bottom is fine. And on the chrominance settings, I'm going to update these to what John suggests as well. Slightly reduce the amount. Structure size reduced down to 2. And then again, per usual, I'll create a preview for this and we'll apply. Okay, so this is very subtly removed any background noise that was created, or sorry, reduced the noise that was created due to our stretches. Okay, so again, subjective to how this may work or not work, or how strong you need to apply to your images. But I'm just going to delete the preview and apply ACDNR to the entire image. And then from there, we can obviously see a before and after that ACDNR has been applied to our stretched image. And I'm just going to remove the mask because we no longer need it, and close down ACDNR. Okay, so the last thing we're going to do with the curves is we're going to adjust the saturation. So we're going to go to curves, transformation, just reset for the image, and we're going to slightly increase or make a slight S curve for the RGB side. I'm just going to put a preview on here so we can see what we're doing. And then I'm going to also slightly increase the saturation of the full image itself. Just so we can turn off and turn on. So again, just improving the colors of the image. So we're going to apply that to the entire image. And next what we'll do is we'll focus just on the stars individually, and then we'll focus on the background. So per usual, we're going to create a mask for this. However, we're going to do it through a process called range selection, as opposed to the masks that we've been making before through the Luminance channel. So for this, I'm going to, let's just reset, sorry, get a preview. And again, we're just trying to focus out or mask out the stars and the cluster in the middle. We could create a star mask for this specifically, but sometimes they don't quite work for clusters of stars, such as this images. So let's just adjust that. Okay, and we'll create a mask from that. So close out our preview, apply the process, and that'll create the mask. And then obviously we need to apply that mask to our image. Show the mask so we can see what's touching. And this way, what we're going to do first is the stars. So the background being red is good, being protected. And curves transformation, let's just reset. Preview, and then we'll increase the saturation slightly for the stars. So we'll go too far, we'll see to bring in too much oranges. We just want subtle touches here. And same for the RGB setting. Apply that. So again, this is like, very personal choice, subjective, how you want things to look. So that's just bringing out a little bit of the stars in the middle. And using the same mask, show the mask, and we will invert it. So this time the stars are protected, and we're going to be adjusting the background. Let's do a reset. And this time we will reduce the background. So we don't want to make it too dark. Let's put a preview on that. We don't want to make it too dark. The background looks a bit false. But there's opportunity to slightly adjust the black. As I said, too dark down here. I want to make these stars stand out nice. And the saturation, of course, will reduce as well. So again, too much, probably removing too much color out of everything. So just, again, subtle changes. And if you go one extreme to the other, it allows you to see a little bit more easier what you're going to be updating or changing. Okay. So remove the preview and apply this to our image. Okay, so the last thing you might want to do is reduce the actual stars if they're a little bit too strong around the cluster. To do this, let's remove our masks. And we can create a star mask for this. Okay, I'm just going to keep the settings as is. New instance to create our mask. And then we're going to use the process morphological transformation. I'm going to set this to about 0.5 just so it's not too strong. We'll see how it runs. Apply that mask. And we'll just double check again. It is the stars that we want white because that's what we're going to run this process against. We'll do a preview for this. And basically you want a shape similar to what I've got here, which is like, star shape, I suppose, are the closest that's going to get to. And we can just run that process on there. And then we can do a before and after the preview, and slightly dims the stars. But if we zoom in, it kind of just takes a bit of the edginess off the stars. So again, very subjective to, you might want to run this, so you might not want to. Let's remove the preview and we'll run this against the entire image, and let's just see what it looks like and decide whether we want it or not. So this is before and this is after. So it has dimmed the image a little bit. On this occasion, I think I'm going to stay without it. So I'm just going to use the undo button at the top left-hand corner here. And let's finally remove the mask. We're not going to use it any further. And that is our image completed. So from here, you can obviously save the image out as a PNG or whatever you want to export it as. Or you can tweak a little bit further or export into Photoshop if you want to, again, amend or continue with any editing of the images. So I think we're done for that on M71. Thank you for watching this workflow on star clusters. As I remind myself constantly, there's 1,001 ways to do things within PixInsight. If you have any advice on this workflow or advice for clusters, not just for myself, but also for others, then please leave a comment below. If you've enjoyed this video, this workflow and other videos on your channel, then please hit the like button and hit the subscribe button to the channel as well. Okay, so thanks for your time, and I'll see you on the next video.